Hi everyone, this is Moni saying welcome back. We are on the Teaching STEM podcast and video series, and I'm continuing on the theme of teaching coding. Hey, this is Moni Singh, an engineer, a creator, a mother, and a lifelong learner. Many people know me as Miss STEM, the founder of the STEM for Kids movement. I created this channel to help you raise your children, your students, for success in this ever transforming world laced with increasing digital influence. You watch these videos because you know that there's something more inside your kids. They got the Elon Musk type of talent hidden inside them. If you haven't done so, hit the subscribe button, and I share regularly. And as a subscriber, you have access to the practical tips, tools, and resources to raise resilient creators. So, we left off last time. Code is nothing but a set of instructions, and we're giving instructions to a computer so it can do what we want it to do. And I was telling last time about it's garbage in, garbage out, or basically whatever instructions you provide is what you get out of a computer. So we are going to do another exercise, and hopefully that starts to bring the point home for you. So for this exercise, I will need for you to grab a piece of paper, any paper will do, and a pen. And if you have some color marker, that'll be good as well. So that's all. And when you do it with kids, that's exactly what you need with them. So we are doing a little activity, unplugged activity with computer programming, to give kids an idea about what programming is. And you don't necessarily need a computer for that at this point in time. Um, Okay, so we'll do this exercise together. So just follow along. When you do it, you'll tell the kids that you are going to go through a little programming experience with them. We are going to give them a simple set of instructions or program. So you can start using the word program. Now you'll say, I'm going to give you a simple set of instructions or a program, and then you are required to follow along the directions. And if something is not clear, it's okay. Whatever they understand, they should implement. They should do whatever they think that instruction means to them. Okay, and even if it's not, if they don't fully understand, just do whatever they think is the correct interpretation of whatever they heard from you. Okay, um, and it's okay if everyone ends up doing different things, following the same direction, and that's possible. So just remember that we are not going to comment until a question is asked. Okay, so you can go ahead and start. Well, right now you can follow along with me as I give you instructions. So at the bottom left of the page, write 3. Then write a plus sign. Then write the number 5. Write equal to sign. Calculate 3 plus 5 and write the answer next. Make a rectangle in red color around what you just wrote. End program. Okay, so the program has ended, and we are going to, at this point in time, if you are instructing this class, you want to look around and compare the results of, what people got as you gave them the same instruction. Everybody heard the same instructions, and you want to look around and see what they did. And then if you see any variations, you want to discuss those variations, right? Why did the variations happen, and how could we, and this could be a discussion point for you with the students, is what could we have done differently to make sure that the desired outcome comes out to be as consistent as possible, right? Because we gave the same set of instructions. So if I were doing that exercise that I just told you, that program, it's a very simple program, right? If I were to do that, this is what my output would have looked like. I don't know about you, but this one was a very simple exercise. If you see on the bottom of that page, I have 3 plus 5 equals 8. Now, when you look around and you look at what the children did, it's possible that the red box, might have been centered for some of them. For some of them, it might have been completely off. Like in my case, you can see the numbers are more towards the right, and they're more sticking to the rectangle on the right hand side, and there's more gap on the left hand side. So we did leave some room for variation there, right? So if it was a computer, the output could look completely different, right? So with children, you'll see that there's a variation there. We didn't talk about the spacing between 3 and 5. So some of them might be squished up. Some of them may have written it quite big. We didn't talk about the size of the characters, right? So like in my case, they are so small, somebody may have written it, maybe they started at the bottom left, but maybe they wrote so big that this 3 plus 5 equals 8 is almost covering half the page. So you'll see those variations, and it's worthwhile to discuss those with the children, again to highlight the specificity of the instructions, right? When we give commands to the computer, we want to be as specific as possible so that we get the exact desired output. Okay, so that was just a simple programming. We are going to extend, do some more with that, just to bring the point home. Okay, so continuing forward, so you can use the same piece of paper, and we'll do like the next set of programming. So again, you can follow along with me as I do the next set of program instructions for you. Okay, so again, the same rules apply. I'm going to give you directions. Do uh, do what you think is the instruction. If something is not clear, just figure out something from your own perspective and just do it, okay? Because we're not going to answer any questions in the middle of the program right now. All right, so the program starts. Write your name on the top right corner of the paper. Put your pencils, pen, whatever you have in your hand, on the table. Okay? Hold your sheet with both hands. Get off the chair if you are sitting, or and then walk towards the wall you are facing. Okay, so I'll start walking. Of course, I'm not going to walk too much. Okay, well, let me walk. So walk towards the wall that you're facing. Once you reach the wall, turn around. So your back is towards the wall. So assuming that that was the wall, of course, I'm going to turn around all the way, and then take 3 steps forward. Okay, so I'm going to go 3 steps forward. One, two, three. Okay, and then I think I say turn back around, and then sit down where you are. So wherever you are now, sit down. Um, and then draw an X at the center of the paper. Draw an X at the center of the paper. Did you draw it? All right. So this is a time when, if you were following along with me, um, you'll basically start saying, and you might have the children start kind of making faces, looking at each other, because remember, one of the earlier instructions I had said, put the pencils or your pens down. So at this point in time, you really have no pen or a pencil in your hand. And so you'll see that happen. And when children start giving that comment to you, that's when you can say, oh yeah, computers work just like this. If you don't give it the right instruction, it doesn't know what to do. So because we gave a wrong instruction in the beginning, we made an error. Okay. Remember I talked about in the one of the earlier session that many times we have errors in our program. This actually was an error. So when I gave an earlier instruction, I said put the pencil down. That was an error because now you don't have that pencil in your hand to actually draw the X, which is the next instruction I gave you. So, so you can tell the kids that I gave a wrong instruction. I made an error, and so if we make an error, we cannot get the computers to do what we want. So now we made an error and we are going to restart. Okay. So this time again, you can go through those steps again, but instead in the step where I said put the pencil down, we're not going to give that instruction so they can keep holding on to their pen or the pencil, whatever they had, and then they can follow along and you can do the same activity where they walked and then they sat down and then we asked them to write an X on their piece of paper. And then on top of the V of the X, on the top V of the X, write your last name. Let me repeat that instruction. On the top V of the X, write your last name. Stand up in place, holding onto your sheets, and program. Okay. Now again, as a coach, if you are the instructor, you'll look around and you'll start commenting on the outcomes that you see for the kids. All right, and then again discuss the variations, right? What happened? Why do we see variations in what the children have prepared? And is there something that you could have done differently about it? Okay, so let's go back to um, our whiteboard here. And if I were doing this program with this activity, so this is what would have happened. I would have drawn a big X in the center of the page. Let me do that. That's the big X. Oh, actually, before then, I had an instruction about writing your name. So remember, when I gave that instruction, I was not clear. I just said write your name. Many times, what will happen is you'll see some people would have written up their uh, full name. Some may have just written their first name. Some may have capitalized it. So because I was not very clear in my instruction over there. But anyhow, we have the name there, and then I said draw the X, and I said on the top V of the X, write your last name. So this is where we'll write the last name. So there we go. Okay. So the outputs will look, of course, you'll see a lot of variations. And again, you can then discuss, right, what created those variations, how we could have perfected the instructions so that we had as least amount of variation as possible as we did this activity. I hope this was helpful, a very simple way, an unplugged activity. So you don't have a computer, but you can at least discuss the fundamentals, the foundations of computer programming with kids. So enjoy doing this. You can, of course, do a lot of different activities with the similar theme, right? It gives a lot more empowerment to kids, having them create some of these simple programs that you guys can all enact. I talked about that in my last episode too. You can have some more complicated instructions like the one I showed you today. So just, have fun with this, and kids really start to understand that basics of computers, the coding itself, by doing these activities. So I hope this was helpful and informational, and we'll catch up again next time. Take care, everyone.